Today we're gonna do ecology. So ecology, it's basically eco refers to environment and logos is science. So it's the science of the environment. So ecology, basically it's the study of interactions between organisms. Now these organisms have to be living organisms with their environment. Basically, an example would be you look at the wolves, how they interact in their habitat. What's the habitat for wolves? Usually somewhere next to the forest, somewhere where there's like mountains, mountainous area. That's where most likely you will find wolves, and it has to be in the temperate regions, which we're gonna learn also later. Now, also ecology, it's comprised of the mass or the sum of all the living community, all the living things and all the non-living things together, which is called, or which makes up the biosphere. Biology. Sphere refers to the earth. So we look overall at the earth, we can call it also the biosphere. And when you talk about ecology, we look at the living communities and the non-living factors and how they interact. Now, biosphere is made up of two biomes. A biome, it's defined by the amount of rain or water plus temperature. That's what is called the biomes. Now, there is two biomes. Aquatic, which is made up of fresh water and salt water or marine, and terrestrial biome, which is basically the land part. Now, this terrestrial biome are characterized by climate and the living organism. Oops. Now, ecologists study environment at all kind of levels. The four levels, the four major levels are ecosystem, followed by community, population, and then you get to the actual living organism. An ecosystem, it's comprised of the living plus non-living part. Biotic, abiotic factors. Community, it's made up of living, different organisms. Different organisms of different species, let's call it like that, different species. A population, it's made up of the same species, so it's individual of the same species. An organism, it's a single organism or a single individual. So that's how basically ecologists study the environmental interactions. Now, as I mentioned earlier, community is a collection of different species of living organisms. Now, in a community, we have this factor which is called, or characteristics, which is called coevolution. Coevolution is kind of like co-worker. Coevolution means basically they organisms affect each other, and basically they evolve together. Co-worker, you do work with your workmates or whatever you want to call them, or classmates, and together you affect each other, but together you evolve together, you get better. So the same thing for evolution, co-evolution, populations affect each other and eventually they evolve as together, as a whole. Ecosystem, as I mentioned right here, it's a group of several species and the environmental factors. So this is the living, and this part right here is the non-living part. Now, in ecological terms, these are called biotic, and this one is called abiotic, the term. Now, this group of several species environmental factors affect each other. They basically affect each other. You see here living and non-living. For example, if I move a lion in the mountains or in the Rocky Mountains, do you think he's going to survive? Most likely not. Why? Because he doesn't have the right abiotic or non-living condition. It's cold there. Lions don't really like cold. Lions usually like to live in the savanna and a little bit maybe just to hide or to just get some shade during daytime when it's really hot in the rainforest. But they're mainly found in the savanna. The same thing with the zebras. If I move a zebra in Michigan, is it going to survive? Yeah, at the zoo, he's going to survive, but he's not going to survive in the wild because it gets cold in the winter, so they are not really adapted. So that's why ecosystem, you look at the living part and the non-living part, and they have to interact with each other, or the non-living part affects the living part. Now, a community has two characteristics: species richness and then relative abundance. What's the difference between that? Species richness, it means basically how many different species. So for example, you have wolves, foxes, dogs, coyotes, ducks, birds, all kind of different species. This shows us how rich a community is in species. Each one of these organisms right here, it's a different species. Now, relative abundance refers to how many of each one we have. So now let's go and count. Wolves, we have 50. Ducks, we have 75. Sheep, we have 300 sheep there. Now, is this a good community? Is it relative good community, which means basically at equilibrium? Looks like it. Why? Because you want to always have the top predators, in this case right here, wolves, to be in the smaller number than the prey itself. If you would have 50 preys and 300 wolves, actually, eventually, there will be a population crash. So basically, when you refer to a community, we look at the species richness in that community, like how many different species we find there, and then we need to count each of the species, what is made up of. And you need to basically determine how many top predators you have and how much prey you have there, because for a community to be at equilibrium or at balance, it has to have less predators and more prey to survive. So at the bottom of the food chain, you have to have a large biomass, we call it. At the top of the food chain, you need to have a very small biomass, because the one at the top feeds off the bottom, and the one at the top actually eats a lot of the bottom part. Now, in a community, we always have to have a keystone species. Keystone, it's kind of like this. This one right here is the keystone. If I remove this one, what's going to happen with the whole arch? It's going to crumble. Same thing right here. If you remove the keystone species from a ecosystem, the whole ecosystem is going to fall out of balance and it's going to collapse eventually. To give an example, Yellowstone. Yellowstone used to have wolves. Wolves were removed about beginning of 1900s. Now, since wolves were removed, the elk and the deer in Yellowstone actually start grazing everything. Now, when they start grazing, since there is no predators around, they can multiply, they can reproduce. The number of grazers, elks in our case, elks and deer, grew so much, or it multiplies to such large number that basically they start destroying the habitat. How is that possible? If you don't have a predator around, you're just going to sit in an area. Then when the grass is gone and the small trees that are about to grow, from seeds, then you move to the next, right next to it, where there is some more grass, where there's new grass. Then once you're done feeding the adjacent area, you come back to the previous area where the grass start growing again. By eventually overgrazing is called, where you keep going back and forth between these two regions adjacent to each other. You actually destroy completely the habitat and nothing will grow, because now this leads to desertification. Desertification is basically you turn the land into desert, desolated land. Now, if you have wolves there, which were reintroduced back in 1800s because the Yellowstone started being affected, they reintroduced a small family of wolves. I forgot how many. I think it was around 20 to 30 or 40, somewhere around there, between 20 and 50. And what these wolves do now keeps the grazers in check. Now grazers, knowing that there is a predator around, they're not just going to sit in one area. They have to constantly move. Where? Not necessarily only to adjacent, they have to move large distances. So it gives enough time for that area to grow. Also, those grazers themselves are going to be eaten by the predators. Now, predators, what's interesting, they don't necessarily eat the strongest one. They usually try to eat the weakest one in the population. That's how basically they weed out, or they allow the prey to keep reproducing and producing more and more offspring, because they eventually have to feed off those ones. So usually top predators feed off the weak one in a prey population. So in our example, wolf was the keystone species in Yellowstone. As soon as the wolf was reintroduced, Yellowstone started, it allowed to recover everything. So now we have everything from the top of the food chain all the way to the bottom of the food chain. Now, in a community or an ecosystem, we have to have ecological succession. Succession means what? One after each other. Now, for ecological succession, or why do we need this ecological succession? Because some type of disturbance that happened to the ecosystem or to the environment. Now, this type of disturbances, storms, fire, floods, droughts, overgrazing, or human activity. For example, if I take the Tesla factory, or I'm going to build a big, huge Tesla factory here in LA, I'm going to go look for a land, huge land, because I need a really huge, I need maybe 70 acres, 100 acres, whichever it is. Now, eventually, I want to return after 50 years of Tesla using the factory. They want to close down because they went out of business. Now, what am I going to do? Am I going to go use that land immediately and regrow my, return it back to the ecosystem or to nature? No. First of all, what do I have to do? I have to push it or make it go through a certain type of succession before I can reintroduce and I can reuse it to grow my crops or whatever I want to grow there, or make it a park for people to go. Now, there is two types of succession: primary and secondary. Primary, it basically when there's no life basically on that soil. For example, deserts or area where there is soil, but there is nothing grown in it. Now, through primary succession, basically what it means, first thing that's going to show up, first thing that's going to grow is going to be some type of lichens. Lichens, what they do, they basically start breaking down the rocks and then start introducing or start putting nutrients back into the soil. Soil is still not there. Yeah, by the way, it's mainly rocks. Then these lichens will basically stimulate some type of vegetation to start growing. Now, after lichens, usually you see small grasses, which will start settling in there. Then after small grasses is going to be taller grasses, then eventually shrubs. And after shrubs, eventually you have those tall trees. And eventually, if you cut those trees, you can use that land or that soil for agriculture. So basically, primary succession starts from bare soil or rock, soil/rock. Secondary succession is the one that I just described, the Tesla factory. Tesla factory. Basically here, the soil was there. Soil already there. The problem is what? Some type of disturbance took place. Soil already there. But there was some type of disturbance, which was what? Tesla factory, which was using all kind of chemical and all kind of other crap there. Now I cannot grow my crops, so what do? I have to go through a basically succession. So what am I going to do here? Basically, I have to reintroduce plants in order. I reintroduce first some plants which will start basically taking the toxic waste out of the soil. After that, I'm going to put plants that actually will grow and reintroduce the nutrients back into the soil. And eventually, I'm going to return it back to agriculture. That's the only way that I can actually grow my crops or return it back to its initial state. So first you have to do certain things before you can return it. But for secondary succession, it starts already with the soil. It's there. It's not bare rock. Now, what's a habitat? That's definitions from here on. Habitat, ecological niche. Habitat, it's the spatial location basically where an animal or an organism has, or it's found, or lives its life. These parts right here would be the habitat. Now, an ecological niche of a species, it's basically an interaction between these species right here and their community, how they interact with each other. So this one right here basically interact with these four, but they don't interact with these ones here. They do not interact with these ones here. Why? Maybe they are predators. I don't know what they are. Whatever they are in the community, they don't like them. But basically, this would be the ecological niche. That's basically the combination in the community of the organisms, different combination and their interaction of the different organisms in the community itself. So this is habitat. This is the region where you're going to find basically a certain species, and then ecological niche. It has this extra word, ecological. You look basically the ecology, the basically what it does in this community. That's what you look at. Now, when we talk about trophic structure or food chain, this one is also called food chain. We talked about the bottom, top, bottom. Always at the bottom, you have producers. At the top, you always have the predators. Now, obviously, predators are large and producers are smaller. Now, what are producers? Or autotrophs, producers or autotrophs. Basically, they make their own food. So who makes their own food? Plants. Plants are the autotrophs. They could be photo, they use the sun, and chemo, basically make their own food from inorganic compounds. Chemo from chemistry. Then you have the heterotrophs, which are the consumers. Now, consumers basically consume heterotrophs. What do they feed off? Everything else from producers at the bottom to primary consumer, secondary consumer, tertiary, and then right at the top, you have the top predators. So secondary consumes on this and the bottom most likely. Tertiary on secondary first and the bottom most likely. And the top predators usually feed off the tertiary, secondary, or primary. They don't really eat grass. Now, who can be, or how do we classify these heterotrophs? Herbivores, plants. Carnivores, meat. They eat meat. Omnivores eat both plants and meat. Herbivores, cow. Carnivores, cats. Cats are carnivores, pure carnivores. Omnivores, dogs. How do I know them? What type of food they feed off all these organisms? Because I look at their teeth. If you are herbivores, you have a lot of molars because you need to grind that food. Carnivores, you have very few, maybe one molar or no molars at all, but you have canines, canine. Now, as an omnivore, you have canines plus molars. Now, if you look at us, what do you guys think we are? Definitely humans are omnivores because we have canines, and then we have molars, a set of molars on the top and the bottom, 3 sets of molars. Now, another type of heterotroph which we really don't see too much, but they definitely live around us, are the decomposers. Now, decomposer or detrivores, they are called detrivores. They feed off dead organic matter, maggots, bacteria, all the other stuff that decompose the dead organic matter. Fungus, it's also a decomposer. Fungus, if you go next to the rainforest, you see a lot of these funguses which basically decompose the trees. Here you could see the actual food chain or the trophic levels. Start at the top, quaternary, tertiary, secondary, primary producers. Bottom, if you look, there is a lot of them. There's a lot of plants. Phytoplankton, if you look at the water, at the aquatic food chain. So at the bottom, you have the phytoplankton or plants if you're terrestrial. So basically this is terrestrial, okay? Or land, let's call it land. And this is water. Now, definitely you're gonna have less killer whales at the top. Why? Because these killer whales feed off what? This type of animals or organisms. They're not going to feed too much of phytoplankton, but even if they feed off the phytoplankton, or zooplankton, how many do they need? Do you think they need only 3 zooplanktons? No, they just need millions and gazillions of this one. So that's why you need a lot of this one at the bottom level. As you get up, you go from many to actual few, from many to few. So remember, right at the top, you have quaternary. In this case right here, you have a hawk, which feeds off the snake. A snake feeds off a mouse. A mouse feeds off grasshoppers or some type of plant like corn. All right, so let's go next on to the major ecosystems that we find on our planet. Now, when you look here, this is the globe. You can see different colors. Different colors basically represent the main major ecosystem. Now, how do we classify the ecosystem? We classify the ecosystem based on the temperature and rainfall, amount of rainfall that we find in this ecosystem. Now, when you look right here, you're gonna notice the different colors. Usually towards the equator and between tropics, you have these really green ones, which are tropical forests. Now, if you've never been to a tropical forest, maybe Hawaii, that's where you're gonna see a beautiful tropical forest. Or if you come from Southeast Asia or by the equator, Africa, or you went to South America, Ecuador, Brazil, Colombia, you're gonna notice there's a lot of forests there. Why is there a lot of forests? Because there is plenty of water and the temperatures are very mild and very nice. Nice meaning what? Basically warm and moist along the all the time. Let's go back here. Right next, also between the tropics and the equator, we have these orangey regions right there. These orangey regions right there, they are called savanna. Major savannas, you're going to find them in Africa. I guess there is some in South America, very few in Asia, but there is a large swath actually in Australia. Remember, Australia, the western part of Australia, it's a complete desert. So savannas, basically, what do they have? They have dry tropical areas, a little bit of non-tropical areas. So here in the savanna, you have 2 months of rain, followed by 10 months of hot and dry and hot weather. So those 2 months when it rains actually create some ponds, lakes there, and those hopefully they last next 10 months so the animals can survive. Now, usually in savanna, you find plants that grow really fast. Within 2 months, they basically start from the seed, they grow, and they have to reproduce. You're also going to find tall trees, very tall trees, usually with the leaves right at the top, because as the weather dries and mostly hot, animals will start feeding off those trees. And if they feed off the trees, if they have a lot of leaves at the bottom, they usually will die. So why? Because they overfeed. They have to feed all the animals. So now if you put them towards the top, you have a better chance of survive for the tree itself. So that's why in the savanna you're going to find tall trees and a lot of dry vegetation, a ton of dry vegetations, and a lot of animals feed off those dry vegetation. Now also towards between tropics and equator, you're going to find these yellow regions. And if you guys notice, there's like really large swath these days of these yellow regions right here. Those are the deserts. Those are the deserts so far, the desert. Now, what do we have in the desert? It's basically super dry there. During daytime, it's mostly hot. Summer's very hot. There is no seasons yet anywhere, but it's very hot during daytime, and nighttime it cools down. Why it cools down? Because water is the one that maintains basically or drives the weather in an ecosystem. But there is no water. Deserts usually are super dry during daytime and super dry and hot during daytime and cold at nighttime. Now, is there a lot of rain there? If it rains a couple of days a year, that's really good. There is parts on Earth where it hasn't rained in 500 years. Atacama Desert, which is right here, this is the Atacama Desert, this region right there. In the Atacama Desert, that's where basically is the driest land on Earth, or the driest desert on Earth. It hasn't rained. There's parts that hasn't rained in 500 years. They haven't seen rain. Next, we have chaparral. Chaparral is defined basically by small shrubs or small, very tiny trees. Now, where do you find chaparral? If you go through Santa Monica Canyons, if you take 101 and then you exit Los Virgenes and then you're going to go towards the ocean, you're going to see a bunch of chaparral there, a bunch of like small trees. Now, how is the weather there? Why do grow only small trees there? Because the winters are mild and somewhat wet. Mild meaning that the temperatures are mild, and summers are dry and very hot. But in the summers, you can still get some of that moisture that comes from the ocean, but it's not enough for trees to grow very tall. So that's why chaparral has small trees. Now, if you look right here, the red regions by the Mediterranean, by in Australia, a little bit somewhere in here by Cape Town in South Africa. And if you notice right here, this little area right here, that's the Malibu area, all the way to Santa Barbara. This is chaparral also. And there's a little bit region right here by Chile too. These are the chaparral. As we go towards north, we start having the temperate region. Now, temperate region could be grasslands called, or broadleaf forest. Grasslands are basically where you have a lot of grasses, middle of the continents. If you notice right here, that's where it is, middle of the continent. Now, Midwest, United States, how is it characterized? We start having 4 seasons, winter, spring, summer, and fall. Now, what happens? Winters are pretty cold and not really long, but pretty cold. Is there a lot of precipitation? Yes, in the form of snow. Summers are pretty much wet and hot. Not extremely wet, but they are somewhat wet. But definitely the winters are very cold. So that's where you're going to find mostly grasses. As you move towards the outside, from the middle, you get the actual broadleaf forest. Now, this broadleaf forest, basically, they get the moisture from the ocean, and this moisture basically helps the trees, or they have enough water to grow tall. Now, for the broadleaf forest, there is enough moisture there in the winter, and the temperatures are somewhat mild. They're still cold. They're still cold winters with snow, but they are somewhat milder than the grassland, the temperate grassland. Summers are mild and towards warm, and they're still rainy. There's still a lot of moisture. As you go even north now, you end up with this region, and these next two, you're going to find them only in the northern hemisphere, because in the southern, there is very little land. If you notice right here, south of the equator, there is less land than north of the equator. Taiga, it's called, this region right here, or coniferous forest. As the name says, coniferous, it basically has a lot of pines or conifers. Now, the regions here, winters are very cold and there's a lot of snow. Summers are shorter, but they are somewhat humid. So here, that's why you're gonna find plenty of pine trees, because pine trees survive very well the cold winters. Summers, as I mentioned, short and somewhat wet. Now, as you go even north, now you pass the 60 degrees north, now you're gonna get the really, really cold weather, which you're gonna find in the tundra. Tundra has permafrost. In tundra, you're gonna find permafrost, which means permanently frozen land. Here, the land is basically frozen. Funerals cannot be held until the land defrost, usually by May. Usually from end of September, beginning of October, all the way to next May, the land is frozen. So there can be no funerals. There can be nothing. It's very hard to dig in land that it's permanently frozen. So in tundra, what type of weather do you expect? Do you expect very small or very, very little vegetation, maybe some small grasses that could multiply during this very, very short summer or reproduce and grow pretty fast? So they have enough time to reproduce. So here it's basically mostly cold most of the time of the year with a lot of snow. Summers, very, very short, maybe a month or so. And they are like in upper 40s, 50s, somewhere there, no more than that, the temperatures. And that's enough for certain grasses to grow. Now, this part right here, as I mentioned, it's frozen or permafrost. And as you go to the Arctic Circle, you have where you have permanent ice and only ice, like in Greenland, and right here at the bottom, you have Antarctica. That's where the actual polar ice is. Now, let's move and see what's going to happen, or what type of interactions can we have in the communities. In the communities, basically, we have different types of interaction, starting with competition. Basically, competition is when species compete for the resource. There is predation, parasitism, commensalism, and mutualism. Predation is basically one species preys on another. Parasitism, it's one species parasites. Parasite means what? It feeds off one. Commensalism, it's basically when one species benefits and the other one is not affected. So one benefits, one it's not affected. Check it out right here. These oxpeckers basically get a free ride. Sharks, there's these fishes that attach to the sharks and then they travel the oceans. Now the shark being large, it does not get bothered by those little suckers that are attached to it. And they get basically a free ride. Do they really affect the animal, the main animal? No. This African buffalo right here is not affected because he has a bunch of birds right there. They get a free ride. So commensalism, one benefits, the other one is unaffected. Parasitism, it's a problem because when one benefits, the other one gets harmed because parasites eat until they kill the host. The parasites, we have a lot of parasites. We have some parasites in our organism. The one that get in our small intestine, they feed off of our food in the small intestine, and eventually we're gonna keep weaken, and eventually if they multiply because there is resources or food that you keep eating, eventually they would kill us. Another type of competition, mutualism. Mutualism is basically both benefit. I give you, you give me something else. Termites and a bug inside termites. For termites, basically, they feed off wood. They eat wood, but they cannot digest wood. So then, to be able to digest wood, termites acquire this organism, which is called trichonympha. You don't need to know the name, but it's called trichonympha. I don't even know if I spell it right, but it's trichonympha. This trichoninfa provides basically the enzyme, which is called cellulase. Cellulase, which breaks down wood. Now the termites can basically feed off that cellulase that breaks down wood into glucose. So basically, trichoninfa gets free housing, and the termite gets the cellulase, or the glucose, gets the glucose. So this is called mutualism. We help each other, symbiotic relationship or mutualism. Now, when there is competition, there's always resources that are limited resources. Now, in an ecosystem or in a community, you have a principle which is called competitive exclusion principle applies. Now, the competitive exclusion principle basically states that no two species occupy the same niche if they use the same type of resources. Why? Because one of them will outlive or outkill the other one. If they feed off the same resources, no two species can occupy the same area. They have to actually move out. It's kind of like us and lions. We cannot occupy exactly the same habitat because we run out of foods. The lions might kill all the meat that we have. So then what do we have to do? We have to basically diversify. So we have to start eating other type of resources. Whoever cannot feed of different resources will die. Also, in a community, since no two two species that feed off or use the same resources can occupy the same area, we have resource partitioning. Basically, this is competition for resources. Now, when we have resource partitioning, as I mentioned earlier, we have to learn how to use different aspects of the habitat. We have to feed off different type of resource, or we have to learn to feed off different type of resource to be able to survive. By being able to survive and start feeding off a different or using different aspect of the habitat, we have character displacement. Basically, something will happen with what? With our way of eating. Maybe we just lose the canine since we do not feed any more meat. We don't need those canines. Canines are there just to rip the meat. So probably we're going to lose them. So character displacement is basically we evolve, so we acquire or we lose certain characters to adapt to the habitat. An example would be the finches we saw last time. Evolution. Finches, what did they do? Finches, they have different beaks. Why? Because they start using different type of resources in the community. We already talked about predation. We already talked about keystone species, competition, already talked about parasitism, commensalism. Now, let's move on to the actual population, which is also part of the ecology. Now, when we talk about human population, they have the most impact actually on any part of the ecosystem. Why? Because we are found in all the ecosystem, including deserts. Even in the deserts, if you go to Death Valley, there is people that live there. Now, Death Valley, as you guys know, does not supply too much food right there. So in Death Valley, there can be too many people surviving or living there off the resources there. So human population, depending on their number, can affect or can make the environment or the ecosystem better along the way. Now, to calculate or to count the number or the human population, the growth of the human population in a certain area, we have to use this formula right here. Growth per 1,000 individual equal the number of birth minus the number of death divided by 1,000. Now, if you go to Tokyo, you're not going to use this formula. You're going to use something similar. Growth per, for example, 100,000 individuals, maybe 1 million individuals. You look for larger numbers here because Tokyo, it's a metropolis and it has a high density of people. High density means many people occupying a certain area. Now, until Industrial Revolution, human population growth was pretty slow. About 1800, there were only 1 billion people, approximately. Now, between 1800 to today, which is 2020, we went from 1 billion to 7 point, I think 2 or 7.3 billion today. So if you notice, population increased in 200 years, about 6.3 billion. How was that possible? Because of the Industrial Revolution. Now, Industrial Revolution allowed us to stay at home, allowed us to basically get supermarkets so we don't go and hunt. Now, if you had to go hunt before 1800s, you spent a lot of time outdoors. You didn't have time to go home, mate, or keep reproducing. Now you had to go find resources. Now, a lot of times you don't find resources, which led to famine and malnutrition, and that led to death of the offsprings. Today, not really, we don't really have that much problem, especially industrialized, where we just go to the market and we come home and we can get laid and then we can make babies. That's what happens. Back in the days, I couldn't go to a supermarket. Doctors, medicine, everything advanced during Industrial Revolution, and it advances as we speak today. Yes, with Industrial Revolution, it can bring a bunch of diseases too, which is true, but because of the medication and because of the number of doctors and advancement in healthcare, we are able to survive and increase and grow our human population. You can see here a graph between 1900 to 2020. Let's assume that's somewhere here. This was a prognosis. This was back in the days. I think it's 2009 it was. So if you look at the death rate over time, it's decreasing. Only here there was a big peak right there. Why? Because of the influenza and the First World War. You look at birth rate, they actually stayed level for a long time until about 1975, somewhere around there. What happened here in 1975? Why did they suddenly start dropping the levels right here? Because it was the introduction of contraception. Condoms, and for females was the pill, that birth control pill. But if you notice, the death rate are dropping at the same time too. Now here by 2000, after 2000, you know, the death rate starts going up. Why do you think is that? And the birth rate, it's assumed that will decrease, and eventually by somewhere at 2100, they will level up. Why? Because we can just keep increasing the rate or the number of people without affecting the resources or the environment. Now, why did the death rate go up? Because population here keeps increasing in age. So here there's a lot of 80s, people that are in 80s and 90s, which will eventually die. There is large numbers. Back in the days, not too many people survived past 60 because of the resources and because of the healthcare system. Now, for population growth, there is two main patterns: exponential and logistic. Now, this one depends basically on the resource availability and the biotic potential. Biotic potential is basically how fast or how much can we reproduce. We as humans, usually we have just one baby. If you talk about a dog, it could have up to like 7, 8, 9 babies. If you talk about a pig, can have up to 15 babies. So this means the biotic potential, how much can we reproduce? Now, if you keep reproducing, you have to have a lot of resources. Do we have always the resources? No. So then what do? Your biotic potential basically adjusts. You're not going to make 20 babies, but rather you're going to make only 2, 3 babies because there's not enough resources. Now, when there is no resources at all, you might not even make any babies at all because you just try to survive. You're more worried about survival. Everything else will shut down. Now, if there is, let's assume, plenty of resources and biotic potential, it's unlimited, and there is unlimited resources, we can have two possible patterns. Exponential, which is a J curve right here. If there is plenty of resources, we're going to keep reproducing, and eventually this one is going to go and it grows to infinite. We're going to get super, super large number of organisms. Logistic growth, it's an S shape. S, it means what? You keep growing here at the beginning because there is plenty of resources. Now, eventually, resources become scarce or limited. And then if they become limited, your growth or our growth will also become limited or will be limited. So at that point, if you notice, it stabilizes, it stays the same. This is kind of whatever we see right here. If you notice, from 1800s, we kept growing, and now it starts stabilizing. That's what it happens if you try to interpret this graph right here. Now, for population growth, we have a carrying capacity. What is carrying capacity? It's basically the maximum number of individuals that the environment can sustain for an indefinite period of time. For example, you go, this is Sahara. In the Sahara, you have this small, tiny region right there, which are called oases, they have water and they have some trees right there. Now, how many people could maximum survive in an oasis? Probably 2 people, 3 people maximum, if they can, 3 people survive. Now, if I move more than 3 people, you start affecting the oasis and eventually the oasis will die. This is what it's called carrying capacity. Basically, the 3 people that this oasis right there can support for an indefinite period, it's called the carrying capacity. Now, what is the carrying capacity of the Earth? I have no idea what it is. People assume that it's 50 billion people. Some people say we overshot our carrying capacity at 7.2 billion. Probably the carrying capacity is somewhere around 4 or 5 billion, but we just basically stretching the resources right now with the advancement in agriculture and other fields. But I don't know what carrying capacity. I believe carrying capacity is somewhere around 6-7 billion in my opinion. But I think that we overshot it. Some people believe, especially Catholics, they believe, oh no, it's 50 billion. We should keep reproducing and have babies. But eventually we already see that the environment, it's affected. Look around us, look at the global warming that's around us. Look at the desertification, the amount of desert, that desert keeps increasing because of overuse of or overgrazing of agricultural land. So this is a main problem these days. Now, as the population increases, the amount of resources has to increase also, which is the problem. Now, this question I pose right here, where most of the growth of population comes these days? Usually comes from low income or third world countries. That's where the most of increase comes. And that has to do with political part and it has to do with the cultural part there. And you can discuss that one in other classes. Now, demography, it's basically the study of population. So what do we study for a population? We try to look at all kind of characteristics to predict how population sizes will change in the future. So we look at natality, mortality, immigration, emigration, and age distribution. Natality is basically the birth rate. Mortality, it's the death rate. You take the number of people dying in a certain area divided by the certain number. Like there is, for example, you go to a village, you're gonna, every 100 people, you count how many people die. And then you do the average and you come down to 3 people per 100. That means that basically a 3% death rate or mortality, it's 3%. Immigration refers people going into a region, and emigration, emi means exit. They exit the area into. Now we also need to look, when we talk about demographics, at age distribution. Why? Because that's very, very important. That tells us how healthy a population is. Now here you can see the age structure or age distribution. This is for developed countries, which looks pretty healthy. You have number of young replacing the older at the top. And in the middle, you have enough to support the old and also support the young ones. Now, when you look at less developed or poor countries, you notice that there is a way larger number at the bottom to replace this top right here. Now, why is that? Because of the problems that are there, less money, less food, less resources. So a lot of these babies actually die very, very young. In some of these poor countries, the average age a person lives is somewhere late 40s, early 40s to late 40s. There is countries in Africa which have expectant life for an individual to be around 50s. That's how far they can go because of the resources. So that's why this age distribution or the age structure, it's very important. Now, also, we need to look how populations or how living organ or not living organ, how humans are dispersed or how human occupies basically the land, which means what? We try to look right here, basically, where or how do they, let's assume that this is United States, map of United States, something like this, right there, and then right there like this. So we try to look basically how they are found or how do they spread out. Now there's regions or parts of United States where they look like this. This looks like a uniform pattern. Now this one here, like for example, Los Angeles, this is the state of Los Angeles. This one right there looks like clumped. There's two regions right here, they are very clumped. And you can have random. Random, it's something like this. Right here. This is not really uniform, but it's mostly random. Where you find resources, you're going to establish a new population. So we have three types of patterns, or basically how individuals spread out or space out. Clumped, clumped right here. Random, these ones here. And then uniform right there. Everything depends basically on the resources. Now, resources could be living or non-living. If the land is good, definitely it's thriving, right? Because a lot of living organisms can survive on the good land right there. Now, let's look at this map right here, where it also shows us the population growth, which leads basically to this age distribution right here. If you look here, most of the population growth, you're going to find it in Africa, as I mentioned, in third world countries or poor countries, all the way to Southeast Asia and South America right here, Central and South America. Actually, Mexico today doesn't have such a high rate of growth. It used to be, I know when I went in 2010 to Mexico, I heard on the radio, they said that in 1970s, the rate growth was 6.2 close or 6.8 children or offsprings per female. Today it was down, at that time in 2010, it was down to 2.2 children per female. So it went dramatically decreased right there. But here basically it shows you the average annual % change of population. If so if you look in the United States, the average change is between 1.0 to 1.5%. But when you look at these red ones, Africa, an orange one, most of the countries in Africa have very high population growth right here, more than 3%. More than 3% means that's 3 per one extra for 100. So after year one, you have 103. Then next year, 3% is 3 point something. So eventually this population keeps growing. So first year, let's say we start with 100. At 3%, next year you have 103 people. Then the year after that, you have 3.0, how much is that? 3.1, 3.1%. And eventually this one, so it's going to be 103.1 people, 103.1 people. Then over a certain number of years, you're going to end up with very, very large number of population. That's how basically population increases percent-wise. Now, if you look right here, the blue one have less, mostly European countries. Japan actually has a negative annual change. Now that's a problem. If you have negative growth, basically there is no young people which will replace the older people that will retire and will provide them with the retirement, with the money necessary for them in retirement. So that's a major problem. Germany had the same problem, and Japan has the same problem. So basically this map just shows us the population growth. So you should be able to understand these type of maps. And that's all about ecology.